Our guest today is from Poland, Grazyna Jasienska. Her book, The Fragile Wisdom, I saw only after getting to know her elsewhere, but for any of you who haven't seen it, this is just a good read in addition to being wonderful science. I think it's probably the definitive book about women's health in an evolutionary perspective for our time. It came out last year from Harvard University Press, and it's just a masterpiece. And she put many years into it, and we're interested to see what she does next. She took her early education in Poland and then spent 13 years in Boston and Cambridge, Massachusetts at Harvard. I believe it was Peter Ellison who supervised your thesis work and postdoctoral work. She's now back in Poland in Krakow at Jagiellonian University, and for perspective for here at Arizona State University, now about 120 or 30 years old, her university is 650 years old. And even if we haven't heard of it, that's just our problem. And for perspective, what was happening 650 years ago here? What was happening here is the Hohokam Indians had the peak of their culture, and floods had just come through in about 1350 and wiped out many of their settlements, leading, along with many other things, to the downfall of that whole civilization. So even before, just at the time the Hohokam were fading quickly, her university was getting going. She's a professor of public health there, and she also has a study site in Poland, in addition to collaborators worldwide, to try to understand evolution and problems with women's health. Grazyna.
Thank you very much, Randy, for your introduction and for invitation. I'm very, very happy to be here. This is such a beautiful area. I was here about 15 years ago, but it was summer, and I didn't realize the spring is, this is I think, the most beautiful part of the world that I ever seen. I'm going to talk about women, and I'm going to talk about very specific part of female health because I'm going to concentrate on reproductive physiology. When we think about fertility in women, obviously fertility is affected by many different factors: cultural, social, biological, economic, and so on. But all those factors really have to work through ovarian function to influence fertility. So everything has to work through the levels of hormones, otherwise it's not going to have any effect. We know we are interested in ovarian function for different reasons. For me, as anthropologist and human biologist interested in human evolution, I'm interested in that from the perspective of evolution of life history. But obviously, ovarian function is very important for female health, and I'm going to talk about that at the later during this talk. We know a lot about ovarian function and factors that are responsible for variation and factors that are influencing ovarian function in women. We know a great deal about adult environment, factors that are operating during adult life of women and why and what they are doing to ovarian function. But we are also starting to learn that childhood environment and fetal environment, so the condition in which a woman was growing up as a fetus and as a child, are also important for ovarian function, so for production of hormones. All those factors are important because of energy, availability of metabolic energy, so how much energy a woman will have for producing children, for pregnancy and breastfeeding. We also, of course, know that there is some genetic variation when it comes to different genes, that they also have some influence of ovarian functions, and I'm going to mention this briefly today. So I'm interested in a very specific group of women. I'm not interested in women who have problems, who have different pathologies. I'm only interested in women who are healthy, who have regular menstrual cycles, who are in a very similar age range, so there is no variation related to age. So we know that very young women and older women have suppressed levels of hormones. due to age. I'm not interested in that. So only we are going to talk about very specific group of women, probably the most women, the higher proportion of women in all populations. In such defined group, I'm interested whether women differ when it comes to ovarian function, because they are so similar when it comes to health and age and regularity of cycles. And if they differ, why? What are the sources of that variation? What determinants of that variation can we identify? For those people who are not familiar with physiology, don't worry much about it. I'm going to just talk about levels of two hormones. If you look at the lowest panel, you will see estrogen, and in fact this is estradiol, one of the estrogens that is produced during the menstrual cycle, and progesterone. So both of those hormones are very important for fertility, for establishing pregnancy, for keeping the pregnancy during the early stages. So if we look at the levels of these ovarian steroid hormones, here we are looking at progesterone, and we are looking at differences among populations. We could immediately see that on the average, women differ in levels of progesterone. All women are healthy, regular menstrual cycles, and yet we see a lot of variation. Women from US have highest levels of progesterone, women from Poland are slightly lower, and then women from Congo are very low. So there is some, among population, variation in levels of hormones. But if we look at women who are from the same population, and here we are not looking at means, but we are looking at the beautiful hormonal profiles. As you could see, this is progesterone, and we get such a beautiful profiles because we are sampling women. Each woman is giving us samples every day during the whole menstrual cycle. This is in saliva, and based on that we could have not just a single measurement but profiles. And looking at those profiles, well, you could see a lot of variation there. This woman with red profile has very low levels of progesterone, woman with blue profile very high levels, and the question is why? If we look at the single woman, and these are 4 consecutive cycles, you could see that each of those cycles has slightly or sometimes very different levels of hormones produced. So this lady is producing relatively low levels of hormones during July and August, and very high levels during October. So we see that we have variation in levels of ovarian hormones among populations, among women in a single populations, and also among cycles of individuals. So the question is, what determines these variations? Why it's there? I'm going to talk about results of the studies that we did in Poland and also in Norway, and I'm going to, this is just a list of collaborators. We did all hormonal analysis in Peter Ellison's lab at Harvard, and of course many of my colleagues and graduate students took part in different aspects of this study. We had about 200 Polish women, 200 Norwegian women, but I'm only going to show you today data that came from study of Polish populations. And what we did very briefly, we took daily saliva samples in which we measure estradiol and progesterone. We had information on body weight and during birth and length during birth, some from the personal medical records. We did a lot of measurements of body composition and anthropometry. physical activity, that women recorded their levels of physical activity daily in a special log that there was constructed. We also had information about diet, and we took blood sample for genetic analysis. Just showing you why, this is sort of the methodological digression, why go to such expense, in fact, because for women collecting saliva samples every day is not a problem, but this is expensive to analyze samples for the whole menstrual cycle. You could see that if we took just a single sample, this is the number of samples. If you took a single sample or just 2 samples or 3 from the cycle, this is not very reliable. Coefficient of variation is very high. So in fact, at least 8 samples of progesterone I needed in order to reliably measure levels of hormones during cycle. So that's what we did. We in fact did 14 samples from progesterone, but 8 would be enough. So in Poland, we work in an area which we called human ecology study site. This is the area of Poland I'm going to show you. This is our university, which is located in Krakow, and the study site is just 70 kilometers from Krakow, so it's very conveniently located for everybody who works there. We work in several villages that are in the valleys between the mountains. Mountains are not very tall. You could see immediately that this is very agricultural landscape. Those people are, most of them are involved in agriculture, and agriculture is small fields located on the slopes of the mountains. So this is not a big scale agriculture, but small family-based farms. This is very beautiful, very clean area of Poland with very traditional lifestyle and very traditional family values. So in fact, in our villages, we are observing the highest fertility rates in Poland. Women have on average 5 children, and you should know that Poland has one of the lowest fertility in Europe right now. We are with Italy sometimes lower, sometimes higher than Italy, so much less below the replacement levels. We have a family right now who has 16 children. We have several families with 12 and 10. So if somebody is interested, like me, in reproduction and cost of reproduction, this is what I'm doing right now. This is a perfect place to work. So we have lots of children in the village, and we are doing some studies on children. They all seem to be very happy and healthy. But today, in fact, I'm going to talk about their mothers. And so we are now looking at the adult environment, so adult lifestyle, and what this does to ovarian function. Mothers are interesting because during some parts of the year, during the harvest season especially, they have very high levels of physical activity. This agricultural work is done by very traditional methods, not because people don't know how to do it by using modern methods, but because of size and location of the fields. So they are on the slopes of mountains, and use of any mechanized equipment, it's very difficult and dangerous. So people are using horsepower and people power. So whenever there is a harvest, basically whole family works. So all women, regardless of age, are working for many, many hours a day, and work is very hard. At the same time, you could notice that this is quite typical woman there. So she's clearly well nourished. So people don't have any problems with diet, especially in terms of calories. They eat very well. And in fact, women, when they are working very hard, gain a little bit weight because they get hungry, they work a lot, they drink a lot of sweet liquids, and so they in fact gaining weight when they are working. But what work does to levels of hormones? You could see those are progesterone profiles for 2 consecutive summers. And we are looking at 2 groups of women. The white profile is from women who are working very hard physically. The red profile from women who are also working but have much lower level of energy expenditure. So you could see that hard physical work suppresses levels of progesterone in women. In fact, the same is true about estradiol. Here we are looking at women who have high levels of physical activity. This is a red profile. And we can see that they are much lower than women who have low physical activity, so yellow profile. So physical work and any kind of, in fact, physical activity suppresses levels of ovarian hormones in women. What else is important? Well, I became interested reading studies in evolutionary psychology, studies about preferences that humans have for opposite sex. And when you look at the preferences of men, well, probably some men are interested in intellectual aspect of females, but in fact, in almost all population, when it comes to the female body and preferences about that, men prefer very particular shape. So men prefer women who have relatively narrow waists in relation to hips. And a woman can be quite skinny or can be have a lot of body fat, but the shape is what's important. So that's the waist-hip ratio is generally a trait that men really pay attention to. And another trait is breast size. So in most population, men prefer relatively larger breasts than smaller breasts. So I became interested whether those male preferences are cultural, meaning that men learn that this is attractive and somehow believe that this is attractive, or alternatively, whether those preferences have some biological background. And turns out that there is a biological background to those preferences. So women who have relatively narrow waists in relation to hips have higher levels of estradiol than women with more sort of boyish figures. The same is true about progesterone. So this hourglass figure is associated with higher levels of progesterone. Breast size, if you look at the mid-cycle and the second half of the menstrual cycle, it's also higher in women who have relatively larger breasts. And for this study, of course, we did not select women looking at large breasts or high breasts, and this was not our criteria for selection. We just took regular women, and then we just divided them based on measurements that we did. So because those 2 traits are usually come together, so we look at the sort of women with different combination of those 2 traits. And you could see that the first bar, women who have relatively narrow waists and relatively larger breasts at the same time have about 30% higher estradiol levels in their cycles than women who have any other combination of those 2 traits. 30% higher estradiol level, we know from studies that were done in Peter Ellison's lab, it's about 3 times higher probability of conception. Well, given everything else equal, it's about 3 times as high probability of conception in a given cycle. So that's a lot. So there are other factors important during adult environment, but I would like to move to different stages of life. So fetal environment. is that important? And here I became interested in sort of investigating fetal environment because we know so much about importance of this stage of life for later health. Whether we are calling fetal nutritional programming or we could call it by other names, we know that if a fetus is developing in energy poor or nutrient poor condition, this fetus will develop with some permanent changes to physiology and to metabolism. So we'll have different traits as adults, different physiology, and different risk of diseases that somebody who developed in a very good condition. So we know, for example, the small babies have 60 years later higher risk of cardiovascular disease, diabetes, and so on. So I became interested whether there is any fetal nutritional programming of reproductive physiology in women. And this is myself, in fact, with my parents. So you could see that I was a very nice sized baby. I'm just a few weeks old here. Of course, the problem here is how do we know about condition? I have women who are on the average 30 years old. How do I know in what condition they were developing? Well, we don't know for sure. We need to look at some indicators, and one of those indicators is size at birth. It's not a perfect indicator of the condition, but that's what we have. So I in fact look at something which is called a ponderal index. Ponderal index is I think the best indicators of newborn baby nutritional status is like BMI in adults. So it indicates the level of fatness of the baby. And so I ask the question whether women who differed in their size at birth differ later as adults in levels of reproductive steroid hormones. So whether we are observing this long-term effect that 30 years later we will still could see some differences. And it turns out that there is an effect of fetal environment. So women who were developing, well, we don't know exactly, but women who were born as relatively skinny babies, you are looking at the yellow bar, have lower levels of estradiol than women who were developing and were born as relatively fat babies, so the dark orange bar. But we know now that, just looking separately at fetal environment, why we know that so many factors during adult environment are important, this is probably not enough. So I became interested whether when we look at size at birth and at the same time as we look at the physical activity at adulthood, what would be the interactive effect of those two environmental conditions at different stages of life on estradiol level. So we are looking at both adult and fetal environment together and trying to see whether there is any effect on ovarian function. And in fact, if we are looking at women who have, as adults, low levels of physical activity, turns out that size at birth doesn't matter. Whether they were born as small babies or larger babies doesn't matter. Estradiol is the same. If we are looking at women who have very high levels of physical activity, so like my women who work a lot, or somebody who would do a lot of exercise, like going to gym or running every day, size at birth also doesn't matter. Whether somebody was born a small or large baby, it's not important. But for women who have moderate levels of physical activity, so this is probably most women today who are trying to be healthy, so have they sit a lot during work hours, but then they are trying to do something very active at the end or sometimes at the beginning of the day. So for those women, size at birth is very important. And I would like to emphasize that and come back to that, because I think this is from the health perspective, this is the most important finding. So for those women, of course, those who were born as relatively skinny babies have reduced levels of estradiol in comparison to women who were born as relatively large babies. And to put all of this together, you could see that green bars are women who have low levels of physical activity. Those who were born with small size, others were born with large size, doesn't matter. Levels of estradiol is very high for those women. Red bars are women who were born who have high levels of physical activity. So you could see the levels of estradiol are suppressed on those women, but regardless of the size of birth, this is not important. Yellow bars are women with moderate levels of physical activity, and we could see that moderate levels of physical activity has suppressing effect on ovarian hormones, but only in women who were born with relatively small size at birth. Women who were born as fat babies, doesn't matter if they are doing just some exercise. So we look at the adult environment, fetal environment. What about childhood environment? Is this important for reproductive physiology? We obviously know for a long time that age at menarche is affected by childhood condition. But how about adult levels of hormones? Again, how to assess childhood condition in women who are already adults? One of the markers that we can use is a leg length, because we know that when children are growing up in good condition, when they are well nourished, they have relatively longer legs in relation to trunk. So we could look at the absolute length, but especially this relative length. This is sort of indication if somebody, doesn't matter how tall is the person, but it matters how much of the height the leg take. So this is sort of the marker of the childhood condition. So right now, we are just asking the question, is there any relationship between leg length and ovarian function of adult women? And leg length we are using as an indicator of childhood condition. We are using, in this, we already know size at birth is important, so we are using size at birth as a marker of fetal condition, and we are adding physical activity as a marker of adult condition. So we are asking, is there a relationship? Are childhood condition important for physiology of adult women, controlling the sort of the what's going on at different life stages? So we are putting all those three factors operating at different life stages to this equation. And turns out, well, leg length is important. So looking at the mid-cycle and luteal phase, so the second half of the menstrual cycle, we could see that women with relatively longer legs have higher levels of estradiol, while controlling for other factors that are known to affect levels of reproductive steroid hormones. Everything, of course, is always affected by genes, and the question is, are levels of reproductive steroid hormones are also, to some extent, under the genetic influence? Of course, we have a lot of different genes that are candidates for causing this variation, but I'm going to only show you a result of the study in which we look at the genes that are involved in estradiol synthesis. Estradiol is, as all steroid hormones, are synthesized from cholesterol, go through more or less complicated metabolic changes, and there are, of course, enzymes that are changing one metabolite to another. And we study many of those enzymes, but I'm only going to show you this one, which is called CYP17. And this is one of the cytochromes that's responsible for activity of two different enzymes in estradiol synthesis. So we are asking the question, do different CYP17 genotypes differ in estradiol levels? And they do. So women who are homozygotes, the red profile, I hope you can see red well, have about 50% higher estradiol than women who have another genotype that are also homozygotes, and heterozygotes are in the middle. And with some other genes involved in estradiol and progesterone metabolism, we also see differences in levels of hormones. So this is in general very, very complicated picture. We have genetic variation, we have lifestyle at all three different stages of life course, and all those factors are contributing to levels of hormones. And I think right now we are in a stage when I'm not doing the study anymore because I cannot investigate this further with sort of the sample sizes that we usually have in anthropology. So now it's up to epidemiologists to look at the interactive effect of all those things. And why epidemiologists should be interested, I'm going to show you in a minute. So we are moving to the health aspects of all this. Why should we be interested in levels of ovarian steroid hormones in women? So we know that when it comes to levels of estradiol and progesterone, they are extremely important for many aspects of female health. In general, we can say it's good to have high levels of these two hormones. I'm not talking about any pathologically high, I'm talking about within normal variation that we observe in many populations. So if somebody has a high levels, this is promoting fertility, this is good for cardiovascular health, this is good for prevention of osteoporosis, and this is good for psychological well-being. So in general, it's good to have high levels of estradiol and progesterone. But there's always some buts when you look at health. And this is the picture which was painted by Raphael, and this is his mistress. We only know her as La Fornalina, so the daughter of the baker. And you could see that Raphael himself died as a relatively young man, but she also, we don't know much whether she died and how long she lived, but in Lancet several years ago there was a paper in which an oncologist argued that this is the first picture of a woman who has a breast cancer. And he said that if you look at closely here, that the coloring, the shape of the breast, what we can see from under her arm, the way she points to her breast, that this means that she had breast cancer. We don't know whether this is really true or not. We know that after Raphael died, she was in fact accepted into a convent, and she did not become a nurse, but probably nurses took care of her when she had a breast cancer, because nurses at the time really had a lot of knowledge how to take care of women with breast cancer, because they themselves got breast cancer often. So we know very well that if a woman has a high lifetime levels of estrogens and probably also progesterone, this is not good for her, because this increases risk of breast cancer, endometrial cancer, and ovarian cancer. So if really levels of those hormones are so detrimental, it's not good to have high levels, what does it mean? We could conclude that in order to reduce the risk of breast cancer, we should reduce lifetime levels of estrogen and progesterone. So reduce exposure to estrogen and progesterone during life. In order to do that, we of course need to understand why women have high levels of estrogen and progesterone exposure in the first place. First of all, they have high levels of those two hormones because they have many menstrual cycles during life. Why do they have many menstrual cycles? Well, there is early menarche, so production of these two hormones starts very early in life. There is late menopause, probably much earlier in modern women than it was in hunter-gatherers or our ancestors. Women have very few children, and women often, if you don't have children, you are not breastfeeding. If you have children, most women are breastfeeding for a very short time. So that's the first reason, to have cycles. But also, it's not only that there are many cycles, but levels of steroid hormones in cycles are very high. You remember the average levels in different populations. If you see American women, the levels of hormones are very high, and there are so many cycles with those levels. So what to do? We know that physical activity is a very powerful factor that suppresses levels of steroid hormones. So we also know from epidemiological studies that did not look at hormones, but just look at the levels of physical activity and rates of breast cancer. We know that women who are physically active have lower risk of breast cancer. Physical activity reduces risk of breast cancer to up to 40%. So it's not like physical activity and cardiovascular disease. Then you could have, reduced risk many, many times. This is 40%. That's what we can achieve. But epidemiologists don't really know how much activity a woman should do in order to reduce the risk. There are no good recommendations. And there are no recommendations, I think, because for different women, the amount of physical activity will be different. And you could see from this graph that so many factors are important. So here we could clearly see that if somebody was born as a relatively well-fed baby, moderate levels of physical activity are not going to be enough for such women to reduce levels of hormones. If somebody was born as a relatively skinny baby, she will have other health problems in her life, but with just moderate levels of physical activity, she will be able to reduce her levels of ovarian hormones and probably, most likely, reduce risk of breast cancer. So in order to really understand how to play with those lifetime levels of hormones, because we can do it. We know physical activity reduces levels, but this is not enough information. We need to put more information into this equation to understand what kind of prescription we could give to individual women. This cannot be just population-based recommendation. This is not going to work. And this sort of leads us to question what is normal when it comes to levels of reproductive steroid hormones. So what is normal in general when it comes to human health? We usually base our understanding of what's normal on studies that were done on Western populations. So whatever you are interested in, whether this is normal, what's normal cholesterol is, or normal glucose, or normal levels of estradiol and progesterone. And if you look at the textbook, if you look at the recommendation, this is based on the levels of women who are living in industrialized, rich countries. And this is probably not normal. This is much too high. Normal would be much closer to what women have in Congo, Bolivia, and Nepal. Women who have high levels of physical activity, women who are losing weight from time to time, so going through weight loss cycles due to the fact that there is seasonal lifestyle. Women who are born with smaller size at birth, and this is probably normal. This is closer to what our ancestors had. So what we have in urbanized population, this is probably just not normal, but much too high. So perhaps instead of normal, we should think about what's optimal. But of course we have a problem here, because what's optimal for one trait, for one aspect of health, it's not going to be optimal for another one. And Randy wrote a lot about that. And here we have levels of hormones that are relatively high would be good for fertility, would be easier to get pregnant and to establish a pregnancy. But at the same time, we pay a price of higher risk of breast cancer. So what's optimal? Even when it comes to risk of different diseases, we cannot find a level which is optimal for women, because what, for example, is promoting preventing levels that are good for strong bones, so prevention of osteoporosis, again, are going to be levels that are detrimental because they will increase the risk of breast cancer. So different traits are, in fact, completely require different levels of hormones. So we really don't have the sort of the either neither normal or optimal is not a good question here, probably. Perhaps the better way even to approach this question is to think about trade-offs, that we always are facing some kind of trade-off. So here we for sure have trade-offs between fertility and risk of breast cancer. And natural selection promoted high fertility, not really worrying about the side effect. And breast cancer, the rates of high rates of breast cancer, it's sort of the side effect of the price that women pay for high potential for having high fertility, not for really having many children, but for this high potential. And of course, natural selection will, if a woman develops in different, as a fetus, as a child, if lives in an environment where it's rich of energy, natural selection will promote high levels of hormones, because such women can afford to have many pregnancies and breastfeed her children for a long time. So she should get pregnant many times during her life. So of course for her, from the point of view of natural selection and reproductive success, is good to have high levels of hormones. But breast cancer would be a prize. Especially if this high fertility is not really is not going to happen. So there is a high potential for fertility, but then women really have just a few children. Another trade-offs are, of course, between risk of different diseases. So it's very hard to find the levels of hormones that would be preventing all kind of diseases and would be in generally good for women's health. And this is, of course, very, very challenging in terms of health prevention in women, because we cannot really find sort of the perfect levels of hormones that would be promoting health in all possible aspects. Something like this just does not exist. And so if you would like to know, Randy already was talking about my book. I'm talking about many, many different aspects of female health besides just levels of hormones and reproduction, and basically pointing out to problems. Whatever we are considering, whether this is physical activity or for other health aspects, not just for lowering levels of hormones, whether this is diet, whether this is some cultural norms and how to deal with that. This is always very, very complicated. And I think for female health, in fact, it's more difficult than for male health. With male health, I think the challenges are for health prevention are in fact not that significant as for female health. So thank you very much. And I'm happy to take questions if there are any. Thank you.
Yeah. You showed a slide of progesterone levels, the red dot line, and I'm not familiar with salivary analysis of progesterone, but theoretically, that woman's anovulatory. Her levels never rose. So
Absolutely.
So
Absolutely.
the question raises two. One is whether or not salivary levels are accurate enough to be that meaningful. And the second is, I'm not familiar with LH testing of saliva, but LH surge would be a good way of detecting ovulation rather than doing it from onset of menses, because women could be anovulatory when they bleed. They could have a short luteal phase and
Absolutely.
so forth. So, any comments about that?
I'm not interested in whether cycle is ovulatory or not. I'm only interested in variation in levels of hormones. And it's absolutely clear that you're talking about this, for example, red profile or progesterone. As the specialists in the area, you see immediately there is absolutely no trace of ovulation here, and we know that. But this is woman, she was accepted to the study because she had regular menstrual cycles, and I'm not sure. Maybe for her the physical work that she did was so extreme that this caused such a reduction in progesterone level. I'm not sure that. So in our study we didn't do any detection of ovulation because I wasn't interested in that. I just want to see the sort of the changes in levels of hormones, and I was less interested whether cycle was ovulatory or not. Although from salivary levels, some people are there are some methods to estimate whether cycle was ovulatory or not, looking at levels of estradiol, level of progesterone, how much it rised since from the base level, and so on. And salivary levels are in fact, I think, very good because in saliva you are measuring steroid fraction that is not bound to protein. So the active fraction of steroids, so biologically active and physiologically active. So this is different than what we measure in serum, but I think equally important or even more important.
So I had two questions. One is you had all this variation in the number of children people had in the beginning. Do you know whether any of these differences in the reproductive hormones is having an effect in that distribution?
No. People often ask me whether we see, for example, birth seasonality in a village, because if we have population when women are working very hard physically during the summer. They should not be able to conceive during the summer, or at least should have much lower probability of conception. So we should have much higher levels of children who are conceived during the winter. But the problem is in this population that, men are blamed for the problems here, because men are working outside the village during the winter. So they are in a village during the time when there is a lot of agricultural work, but during the winter there is nothing to do. They go to the cities and work for wages. So in fact we don't see seasonality of birth. So there are no seasonality of conception, because in some parts of the year women have lower probability of conceiving, but in other parts of the year women have high probability of conceiving, but men are not there. So basically we don't see much. Even we also, for those villages, we also have historical records. We have a demographic records when it goes back to mid 18th century. So which was kept by the church, and it's a perfect record, very, very nice, and we have it in our computer base already, and we don't see seasonality of conception in this historical population either. So probably people had the same lifestyle.
Okay. And also you don't get inter-individual variation. So I was more wondering about whether the women who have higher the inter-individual variation is also affecting the inter-individual variation in number of children.
We don't know that, because the women that I show, some of those women when I showed the number of children, some of those women were not in a hormonal study because they are already post-reproductive. Okay. So of course there's somebody who had 16 children, she's done with her reproduction. And for younger women, we don't know how many children they will have.
Okay. And the connection between the fetal size and the adult hormone levels, in that connection, is the data controlling for their adult weight and nutrition? So for example, if there's a correlation between the mom's environment and the daughter's environment, couldn't that happen also because bigger babies are now healthier also?
Mm-hmm. So we in most analysis we controlled for many factors. I didn't want to show you that regression tables or anything like this, because I think this is boring. But if you like, I could send you some publication with that. So we controlled for many different factors. In fact, most people who are doing the study in sort of human reproductive ecology do not find any effect of female body weight. So the weight loss is a very powerful factor for suppressing levels of hormones. But whether a woman is slightly higher, slightly lower body weight doesn't matter. The extremes do matter. So being very skinny or being obese both were lower levels of reproductive hormones. But the high variation of body weight that we observe is in fact not very important for levels of hormones. So in most of those analyses I did not control for body weight. Fat percentage is also not important. Changes, yes, but the actual levels not. And we did not accept it to the study women who were with very low or very high body weight. So there is sort of the normal body weight only.
Thank you very much. It was a really fascinating talk. So I have a question about an observation, and then I wanted to find out what your thoughts might be on a possible explanation. So I work with hunter-gatherers in Latin America for many years, and I had an interesting event take place, but I'm not an endocrinologist, which was that Ache women, this is the group Ache, they made a transition to settlements from being very physically active. So a lot of things changed. And they started having too many babies. So the birth interval, the whole story, 4 years, down to a year and so forth. What happened was that the women really wanted desperately for contraception. they kept saying, why are we having so many, why are we getting pregnant so often, and so on. So I said, okay, if you want contraception, let's get it, but we have to follow this protocol. So 15 women enrolled in this program in the community, and I trained a healthcare worker to learn about how to administer the pills, et cetera, et cetera. So I left that program going and then went back 6 months later, and the 15 women had stopped taking the pill. So I went and I interviewed all of them, and they said, it's hell to take the pill. Even though I had consulted with Claudia Valencia, so we would give them the lowest levels because, you know, of hormones, right? And so I asked them, you know, one by one, you know, what did you experience? And it was ridiculous because each independent answer was so similar. I felt so weak and depressed. I didn't want to live anymore. And then I said, well, if you had to choose between having all those babies and that feeling that you're getting, what would you rather do? And she said, I'd rather have 20 babies any day. So whatever it was so horrific that all the women went off the pill. And I just wonder what your thoughts are on that.
You know, I think that I try to address this in the book a little bit. And if we have our norms for anything when it comes to human health based on Western population, then medication, if we try to give medication or hormonal contraceptive or hormonal replacement therapy or whatever to population that perhaps had very different levels of hormones, let's say, during her life, this could be very problematic. So I think for those women, even the lowest dose in a pill, but it was still a pill designed for industrial population. I think, you know, we have a specialist here, you know, the practitioner here, so he would probably have much better answer than I do here, but I think this is just much too high for those women. Their physiology never experienced such a high levels as you are giving in a pill. And I think, you know, this is sort of interesting because we have this controversy and different studies show different things, whether hormonal contraceptive increases risk of breast cancer. And in fact, different studies show different things. For some women, this is in fact protective. For some women, this may increase the risk in some populations, some groups. And I think that if somebody during her life produces very low levels, so what they get in a pill is much higher than they would usually have when they were just producing hormones naturally. So for such women, I think that they could experience, in fact, increase in risk of breast cancer because they will have higher exposure to hormones. But if somebody has high levels, then the pill, in fact, may have lower levels than what somebody would produce.
And that makes a lot of sense. I just want to add a little bit to this picture, which is that physiologically speaking, a huge difference between these women and the women from the same group who then become acculturated. Once they become acculturated and move on into different environments, then they do take the pill and they do tolerate it. So changes happen so quickly. But one of the biggest difference that we have found between in my area that I study is that the levels of immunoglobulins are absolutely brutal in the populations that are most unacculturated. And the other difference is, so their microbiomes are totally different, which is another area that I think all these things are interacting. And the other component that I find fascinating is that these women also have extremely low blood pressure. So it's the host in these extant EEAs are so different in so many levels, and 0 cases of breast cancer to this day. 0, none. So I will stop there.
No, we're running short of our time.
Okay,
I'm
go
trying
ahead.
to make these things stop on time, but I would like one more question, please.
Oh, thank you. It's very, very striking, interesting work. I'd never heard of it before, and but I can't ask about the medicine. But I am curious a bit about the statistics. You have a sample of 200 women, and it's very intense, as you say, and very expensive. Requires daily measurements plus intense body measurements. You even go back and get birth weight and birth information. So I'm leads me to ask wonder a couple things. One, are you concerned at all about the selection bias? Even though it's 200 people, there's a much larger population. How representative do you think it is? If you can ask.
Absolutely. You know, this is we are not selecting participant randomly. Yes, if I were doing the large epidemiological study, I would be very sort of careful about taking random samples. This is not a random samples. Those are volunteers, and also they are not only volunteers, but they really need to fulfill some requirements, some criteria. So I'm rejecting women who have either menstrual irregularities, any kind of hormonal problems, and so on. So I'm taking basically, you know, healthy women with very particular sets of traits, and I work on that. And
Are any on the pill?
no, absolutely not. This is the requirement. No on a pill, and at least 12 months break since they last took the pill, 6 months break since they had a child or breastfed a child. So, you know, there are many different sort of criteria. No, so we are trying to just really take women who don't have any other factors that would influence levels of hormones. But selection bias, you know, it could be always there. With if you are working with volunteers, that's the problem. That maybe we are getting women who. No, it's hard to say. It's hard to say. We just advertise for the study that we are going to do a study on ovarian function in women, and whether this created any bias, hard to say.
And just briefly, I don't know any of the other literature on this, but are there any comparable studies that are showing similar results? You mentioned your Norwegian study and so on.
Yeah, Norwegian study was exactly our sister study. So I did this with collaboration with an epidemiologist, in fact, in Norway, and we did roughly the same things in both. And then when we started analyzing results, each of us was interested in different questions. Epidemiologist, obviously, she asked more sort of medical type of question. I asked more for me, you know, sort of evolutionary type of question. So, but some of those are the same, and there are in fact studies like physical activity. Our study was the first one that showed the effect of physical activity in women who were not losing weight, and of physical activity that was occupational physical activity and not exercise. We have a lot of studies on exercise that show the same effect. Weight loss was replicated by many studies. I'm waiting for somebody to look at size at birth and show the same. I never saw anybody doing this. Body shape, no.
Thanks again, Grazyna.
Thank you.
Really appreciate you coming
Thank you
here.
very much. Thank you.